Hey guys, welcome to 2.4 day 2. This is point slope form. Our essential question: how do you write and graph equations of lines in point slope form? So far we've had slope intercept form, right? Y equals mx plus b, where m is the slope and b is the y-intercept. Then yesterday we talked about standard form, ax plus by equals c. And that was really nice because we'd plug in 0 for y to get our x-intercept, and then we'd plug in 0 for x to get our y-intercept, right? And so that was a nice way to find the two intercepts. Now today we're going to be talking about point slope form, which is modeled by the equation y minus y1 equals m times the quantity x minus x1. Okay, and y1 comma x1 is a point on the line. Okay, so sorry, this is backwards. x1 minus y, or sorry, x1 comma y1. Let's get our point right, huh? x1 y1. There we go. That's a point on the line. M is the same as it was up here. M is the slope. All right. Now, key thing to remember here is that this is a minus sign right here. Y minus whatever this number is, right? So if this happens to be a negative number, it's actually going to turn out to be y plus, so if this was -3, this will be y plus 3 because two negatives make a positive. All right, so a line passes through -1, 3. It has a slope of -2/3. We need to write the equation of the line. And ask ourselves, well, which equation is the least amount of work? And the answer to that would be point slope form, because we have our point, right? This is x1, y1, and this is our slope. And so literally we can just plug it in to our y minus y1 equals m times x minus x1. Right? And then we just plug in our point. So y minus our y value is 3 equals our slope is -2/3 times x minus -1. Remember what I was talking about with the negative sign, right? And so actually this becomes a positive, and we're done. Okay, a line passes through 5, 1, and 7, 9. What's the equation of line in point slope form? Well, first we need to find our slope, right? Because we have points, but we don't have a slope. So remember that's y2 minus y1 over x2 minus x1. All right, so then we plug in our points, and we get, let's do 9 minus 1 over 7 minus 5. That'll get us 8 over 2, which is the same as 4. So our slope is 4. So we put it in here, y minus y1. Now, which one do we use? Which point? Well, the truth of the matter is it doesn't matter. You can do either one. So for the first time, let's do the first point here. So our y is 1. Our slope is 4, x minus 5. Or you can choose to do y minus 7, do the other point. We have the same slope, and x minus 7. Oh, I messed up. I'm sorry, this is 9. Y minus 9. And then x minus 7. All right, so it doesn't matter. Either these are the same line. They just look slightly different. All right, so now we're going to write an equation of each line in slope-intercept form. So basically what we're going to do is we'll write it in point slope form, and then it's a fairly easy change over to y equals mx plus b. All right, so y minus -4 equals m times x minus, in this case, 1. Okay, now this turns into a positive, right? And then all we're going to do is we're going to distribute. Okay, so y plus 4, so we got to turn it into slope-intercept form. Okay, so negative 3x plus 3, and then all we have left to do is subtract 4, and we're left with y equals negative 3x minus 1, and there's our slope-intercept form. So you can see it's not too bad to switch between those two. For this one, we have y minus 3 equals our slope times x minus the x coordinate point. Okay, and we got y minus 3. Be careful not to add this 3. I mean, you can, but just save it. Just save it for later. Okay, save it till after you distribute. Half of 2 is 1, so negative 1 there, and then we're going to add 3 to both sides, and we get y equals 1/2 x plus 2. I forgot my x in there. Sorry, 1/2 x. No. The cost of a taxi ride depends on the distance traveled. You paid $8.50 for a 3-mile ride, while your friend paid $18.50 for an 8-mile ride. What's the equation of the line that represents this situation? Well, first we need to figure out. Let's make our dependent variable is kind of the y, right? And so which one depends on the other one? Well, how much we paid depends on how long the ride was, right? And so the money is going to be our y value. And so the first coordinate point is going to be for a 3-mile ride, it costs $8.50. Okay, and then for an 8-mile ride, it costs $18.50. All right, so now we have 2 coordinate points, and now we can find the slope of our problem here. And so let's do 1850 minus 850 over 8 minus 3. So that gets us 10 over 5. So our slope is 2. Okay, because we're going to write an equation of the line that represents this situation. Obviously, it's kind of a linear situation, right? There's a constant rate for mileage, so your line goes up the more distance you travel. So we found our slope is 2. So now our easiest formula is point slope formula, or point slope form, and so we can use either point. Okay, so we could do y minus 850 equals our slope is 2, and x minus 3, or we could do y minus 1850 equals 2 times x minus 8. Either one works. They both are sufficient for our problem. All right, what's the equation of a line perpendicular to negative 2x plus 3/4 with the same y-intercept as this line? Interesting. Okay, so first off, over here we know that our slope is negative 2, right? So that's our m. And it says that we need the line perpendicular to it, right? And so the line perpendicular to this one is going to have a slope of positive 1/2, right? Opposite reciprocal slope. So our new line is going to, our perpendicular line is going to have opposite reciprocal slope from here. And then to figure out what the y-intercept is going to be, that needs to come from this equation, right? Because we want the line perpendicular to this one, but with the same y-intercept as this one. Okay, well, this one's in standard form. How do we find the y-intercept in standard form? We plug in 0 for x, right? And so we plug in 0 for x to find the y-intercept. And we get 3y equals 12. And so we know that the y-intercept is at 4. Okay, so in our problem, b equals 4. Now we can just write it in slope-intercept form. Our slope is 1/2 x plus b, which is 4. Okay. So, line perpendicular to this one, well, we had to do opposite reciprocal slope to get 1/2. We knew that the perpendicular line had the same y-intercept of this one, which was in standard form. We plugged in 0 for x to find our y-intercept, and and that got us 4. And then we could just plug both elements into our equation. All right, that's it for section 2.4, day 2. Here's your practice problems, and we'll be on to 2.5 tomorrow.